All right, now that you've finished assignment 6B2, in class you'll see tomorrow this. You have to write down the formula that relates fraction of a circle to distance, what pi radians is equal to. You'll have to label the unit circle with distances and coordinates. You'll have to say what is sine s equal to, what is cosine s equal to, and what this is here. And then I'd also like you to sketch the graphs of sine and cosine. You don't have to do amazingly beautiful detailed graphs, but something like this would work. So just to make sure that sine starts here at the origin and goes up and down like that. You could even label this 2 pi if you wanted to. And then boom, 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 label this negative 2 pi. Cosine has to start with along the y-axis at the point 0, 1 right here. So there's your unit circle. Sine s is equal to v, cosine s is equal to u, comma v. That's the important stuff you have to have memorized, and of course the unit circle right here. It's really important to make sure you have these things, that you can either figure them out on a quiz or have them memorized cold, but memorized would be a little bit better because then you won't have to spend so much brain power on things that can be memorized. You can instead focus on higher level things, like what we're going to talk about today. On section 631, this is the other basic circular functions, day 1. So we know that sine of s is equal to v, and we know that cosine of s is equal to u, but there's other ways that you can use u and v in fractions. First of all, you could combine them together. Tangent of s would be v over u, which is the same thing as sine of s over cosine of s. This is also the slope. If you pick any point on the unit circle and you want to find the slope between the origin and that point, it would be the change in y, which is v, and the change in x, which is u. The tangent of s would be is very closely related to slope. I have sine of s over cosine of s memorized. Cosecant is here. This is cosecant of s is defined as 1 over v. This was v. So this is 1 over v, the reciprocal. And it's the same thing as 1 over sine s. Secant s, u is cosine of s, so secant s is going to be 1 over u. It's reciprocal. And the cotangent is going to be the reciprocal of tangent. V over u is tangent, and now cotangent is going to be u over v. Cosine s over sine s. It would just be really helpful to work with these and then eventually have them memorized, sine v and cosine u, and then reciprocal pairs. Sine goes to cosecant. These two are reciprocals of each other. These two are reciprocals of each other, and these two are reciprocals of each other. So now we have not just 2, but we have 6 different functions. So given any distance around the unit circle, we can find not just u and not just v, but we can find sine, cosine, tangent, cotangent, secant, cosecant. Here's how we do that. If it says to find any of these, then the first thing you do is you draw a unit circle and you figure out where on the unit circle that distance is. A distance of 0 would be right here, starting right here, and we can see that it's the point 1, 0. So v equals 0 and u equals 1. So therefore, here they are, 1. U is 1, v is 0. So then therefore sine of 0 is equal to 0. And cosine of 0 is equal to 1. That's old stuff. The new stuff is now we can start combining them into these other functions too. They all have applications, but for right now, this is how they're defined. Tangent of 0 would be v over u, which is 0 over 1. Simplify that, you get 0. Cotangent of 0 would be 1 over 0. That's the reciprocal of tangent, and you can see that's undefined. Secant would be 1 over the cosine of 0. We knew the cosine is 1. So the secant is the reciprocal of cosine, which is just 1. And cosecant is the reciprocal of sine 0, which is undefined, because remember, sine was 0. And the reciprocal of 0, it's undefined. Here's a second example. Boom. If you want to find any of these, if you want tan pi or cotangent of pi or secant of pi, cosecant of pi, you draw a unit circle. That's the first step. You got to figure out where that point, where the distance of pi is along the unit circle from the starting point over here. That's halfway around the circle. That's pi, and it's at the point -1, 0. I want to take a moment right now to talk about the Everglades National Park. I went there when I was in 10th grade with my family. Have you ever been there? I want you to let me know. Everglades National Park in Florida. So, if you want to find the tangent of pi over 4, or cotangent or secant of pi over 4, or any of these, what you really got to do is draw a unit circle and then make your way pi over 4 distance around there and stop right there. You can see this is the 45, 45, 90 triangle. This is the u and v coordinates are square root of 2 over 2, or comma square root of 2 over 2, or the decimal equivalent of about 0.71. So anyway, v equals, you can use these somewhat interchangeably. I think the textbook uses exact fractions. Anyway, it's u equals this and v equals this, so you can see right here. And so therefore the sine of pi over 4 is going to be 0.71. The cosine of pi over 4 is going to be 0.71. And from that you can get tangent. The tangent is sine over cosine, which is this 0.71 over 0.71, which equals 1. You can even see the slope right here of this line going from the origin up to here is going to be 1. So the tangent of this is equal to 1. This is the slope of the line. Cotangent would be the reciprocal of that, which is also the same thing. It's 1. Secant would be the reciprocal of cosine, 1 over 0.71. Or you could even just flip this fraction, 2 over square root of 2. And you'd get the square root of 2, which is equal to 1.4. I want you to do the cosecant, and you can do it in decimal form, which is fine. Let's see. Example 4. Let's go pi over 3 around the unit circle to this happy little point right here. You can see this 30, 60, 90 triangle. The opposite of the 30 is the 0.5, and then the shorter leg is 0.5, and the longer leg is 0.87. And when I say 0.87, I really mean the square root of 3 over 2. I think your book might, like I said, again, use this, but we're going to use these just for handwriting. It's just going to be a little faster, I guess. U equals 0.5, v equals 0.87, and then sine of pi over 3 is the v coordinate, and cosine is pi over 3 is the u coordinate. But then you can move on to the happy fraction of tangent, and you get pi over 3 is equal to the sine over the cosine. And if you do that, you get 1.74. Cotangent would be the reciprocal of that, and you get 0.58. You can do this with decimals, or you can actually manipulate the radicals in fractions. Secant would be the reciprocal of cosine, and cosecant would be the reciprocal of sine. 1 over cosine and 1 over sine. That's it. Copy the problem list and start assignment 6C1. I'll see you in class.